Hi, everyone, and welcome to Örebro University for the final seminar of the AI.ALL project DASH. Hybrid meeting, so we have visitors here. You're very welcome, but also for you digital visitors, you are just as welcome. For you online, please write tons of good questions in the Q&A. And if you have any problems with the technical parts, then let us know as well there. And we will save the questions until the end of the program. My name is Anna Tundel, and I am project leader here at the university for the AI.ALL project. AI.ALL is a European regional funded project that runs here, where we both we help out the society with different solutions within AI, and also give the opportunity for the researchers to I lost myself here in my English words, to validate their research as well, which we think is great. And here today we have the DASH project, but that we are going to talk about with Ravi Chadalavada, that will come up on stage here, and the remaining project partners as well, which you want to present them here soon. But first, before that, I would like to welcome up Professor Amy Lutfi, who is Pro Vice Chancellor of AI and Innovation here at the university, to welcome everyone here.
Thank you very much, Anna, and welcome everybody to this final seminar of one of the many projects that we're doing at the university that combine two very exciting areas, the area of AI and the area of innovation. And as Anna said, my role as Pro Vice Chancellor is to have sort of a strategic view on certain topics, and I'm lucky enough to have both topics of AI and innovation on my desks. So today is like one of those great days where you get to see the final results of a lot of the hard work of not only the researchers, but also those who are working with our innovation system. And I think really one thing that's worth lifting here is that it is teamwork that is the core of reaching these types of results. If we take it from the perspective of the innovation system, what Ravi has achieved is not only a fantastic idea, but also he has demonstrated the ability to use the entire system. That means working with our innovation office that helps researchers realize their innovations, working with the collaboration platform, and working with projects like AI.ALL that helps those innovations to do a little bit more of technical development, which is very needed, as well as helping those innovations to test with end users, and then working with also those partners outside of the university that work with innovations like our regional incubator. So I think it's really exciting to see all of that come to fruition. And even though today is maybe focused on one particular aspect, it's always important to keep in mind that, as we say in English, it takes a village to raise a child. And I would say it takes an innovation system to create an innovation. Then I would like to also say that it's very exciting to see what has been developed within the DASH project and also within the actual innovation itself, from the perspective of being someone who researches and works within the area of AI. Because what we're going to see today is really an example of how AI is a transformative technology and how AI can be used for the betterment of society for many different types of end users. So we're really combining these two very interesting aspects of AI and innovation. And even though this is the end seminar for the DASH project, I feel very confident in saying that this is just the beginning. So thank you very much.
Thank you, Amy. Everything working? Good. I heard something. Great. Thank you. And with that, I would very much like to welcome Ravi on the stage. It's all yours. Please go ahead.
Good afternoon, everyone. I'm very happy and grateful that I'm able to be here with you all today, not just physically, but also virtually. I'm very happy that you could all make it today. And today is a very special day for me. Not just because we have a great idea that turned into DASH project, and now we have good results to show you all and show you the future of where we are going from here. Like Amy said, I really feel that this is just the beginning, and DASH is a fundamental stone to a very big future that we are going to build. And another milestone for me personally is that this is my first project that I wrote a proposal for and received the funding, and now we completed it. So I'm very happy about that, and I'm happy that I could share it with you all. So with that, I will go into the presentation. So the DASH project, it started from an idea that I got from my research, and I'm very excited to share more about it. First of all, we are very, very grateful from so initially when I had the idea, I started it with my team members at the university, and we all discussed like, yeah, this is a cool idea, let's do it. And then we started to approach different people who might need this project and speak with them about it. And we are extremely grateful for the people that we got to meet during this process. And for example, we have a geriatric clinic, which is our main project partner in the DASH project. We have Mikhail here, and also Adrian virtually. And we also have VTI, which has been a great contributor for this project. It is Jan and Henriette there. And we have a reference group with the traffic schools and also traffic worket. So this project started in September 2021, and we recently finished the project in June 2022 with the experiments. So let me briefly tell you a little story about QtPi. So I will tell you why it's called QtPi in a bit. But it all started with my PhD in human-robot interaction in industrial logistics, where I used eye tracking as a tool for intention communication and intention detection. So here is the environment where I used to work in my PhD. So you have this industrial forklift and an industrial worker, and then we try to make the communication between these two entities go smoothly. And here is a short video of what I have done during my PhD. I can scroll through the video a little bit. So here, what you see is a robot trying to communicate what it is going to do in the next few seconds. And the green dot represents where is the human looking. What you observe in this video is the robot is reacting to where the human is looking at. So if the human is looking at the robot, it doesn't blink. And if the human is not looking at the robot, it starts to blink. And the idea here is that in an industrial environment where these forklifts are moving at a rather high speed, if the human is unaware of the robot's existence, it starts to blink to get the human's attention. So this is to ensure safety in these industrial environments. So yeah, so that's my PhD. And now QtPi, what is up with the QtPi? So it has something to do with the driving evaluations, and it doesn't have a direct connection if you see both these things together. But what happened was a rather funny story. It was time to get my Swedish driving license after driving for about 15 years in India, and also here with my Indian license. And when I went to the traffic school, one day before my exam, the traffic school instructor canceled my exam the day after, saying that it's impossible for me to pass this exam because I'm not turning my head enough. And I used to think that I'm a good driver, having driven in conditions like that. I never had any accident. So that is where the idea started to click. And then the next day, I went to the exam anyway in another city, and I passed the exam with no remarks. So that was good news. But that is where QtPi started. Like, what if I use eye tracking as a tool to understand where is the driver looking at? So similar to what a traffic work at the examiner does, and also a traffic school teacher would do. So QtPi stands for a quantitative tool for practical driving improvement and examination. So it is an intelligent, data-driven driving assessment to objectively measure the driving skills so that the teaching, the learning, and the examination of driving skills can be optimized. So the DASH project, it's a branch out from the QtPi, where we apply QtPi for healthcare applications. And DASH stands for Driving Assessment in Healthcare. And we use semantic eye tracking in the DASH project. So coming to the problem, in healthcare and in connection to the traffic safety, there are some groups where at an elevated risk of having a fatal traffic risk. And these are the groups, which is the elderly, neurological disorders, and psychological disorders. And these are the numbers coming from the US. We couldn't find all the numbers consistently in the Sweden. That's why I'm using US as a representative of this. And the disturbing thing is that the numbers of these groups is already very high, and the populations of each group are steeply increasing as well. So, and the resources that we have today to conduct the driving assessment are very scarce. So there is a very pressing need to be able to scale up the solution so that it can reach more people. So you can see elderly is one of the biggest risk groups who are at a risk of a traffic accident. And the population of the elderly is growing at a very high pace. And also the elderly people are at a higher risk of a fatal crash, similar to how a teenager would do. So this problem it's a complex problem. Driving involves a lot of things that we never really notice. Even I didn't notice until I started working on this. So it's a very challenging to understand how good a driver one person is. And it becomes even more challenging when you mix it with the medical side of things. So when a doctor meets a patient or any healthcare professional who is responsible for that, it is tricky for them to understand how that health condition is affecting the patient. So the way that these exams are done today is using neuropsychological tests, which is a questionnaire-based method, where the patient is given a questionnaire and they answer these questions, which is good for today. But the drawback of this method is this, that it is an indirect measure. It may not completely be accurate about how good this person drives in the real world. So the tests that are done today, other tests are vision tests, simulator-based tests, brain imaging, and the golden standard is usually on-road tests. The on-road tests, while they are golden standard, it is a challenging thing that it is expensive and it may not be practical to implement on a large scale. And these are the disadvantages of the driving assessment methods today. They're indirect, they're inefficient because a healthcare professional is required to be with the patient for the whole duration of the exam. And it's also inconvenient for the patient because they have to visit the clinic multiple times, and it's expensive, and they usually have long queues. In Stockholm, I read in a report that they have a waiting time of 8 to 9 months to conduct a driving assessment, which is quite high. And the key issue here is, during this waiting time, there may be a dangerous driver on the road. And that is not good for that person and also for the general traffic. So, and also it comes with a bias that, for example, these neuropsychological tests, while they are the best option that we have today, they may have a bias with the patient group. For example, if you meet a truck driver who probably driven a truck all his life, and but maybe they're not so good with theoretical approaches. So maybe they don't perform that good on this exam, but maybe they're a really good driver on the road. And similarly, with the simulator-based tests, a drawback there is that a teenager who played all his free time on a joystick is maybe very good at playing on a simulator, but maybe an 85-year-old person is not that good. Even I'm not that good. So that is a drawback with this kind of tests. They are there for a very specific purpose, but I believe that they are not the best solution there is. And also another drawback with the current methods is that they are designed to do this test in an episodic manner. So you do a test for about 30 minutes, and that is it. So there, if you want to do a continuous approach in this assessment, that is not possible. So that is where QtPi starts to address these issues. So QtPi is a patented driving evaluation AI that uses drivers' implicit intentions and actions to objectively evaluate real-world driving in compliance with the traffic rules. And it can do all of this without requiring the presence of an expert in the vehicle. Of course, the expert can be there, but it can work even without an expert. And we will tell more about it soon. So this is how the QtPi works. So we have eye tracking, the first component. it helps us to understand where is the driver looking. And then we combine that with the semantic aspects of computer vision, which will let us know what is the driver looking at. And then we combine that with the data from the vehicle, which helps us to understand what is the driver doing. So we have this holistic perspective of these three actions. And then we compare that with the guidelines from the traffic worket and the traffic authorities of what should the driver be doing in that situation. So we compare these two, and then the QtPy generates a report and a video segments, which highlights what are the wrong things that the person is doing. And it uses all of this information to determine if this person is fit to drive or not. And if the answer is no, it also explains why. So this is how practically the setup of QtPy would look. So the driver is sitting in a car with a pair of glasses connected to a phone. And with this equipment, we can understand all the data. We can gather all the data that we need to do this evaluation. And the good thing with this method is it's universally compatible. So it works in all existing vehicles without requiring any modifications. And it also works with all eye trackers in the market. We use one eye tracker, but we are not building eye trackers. We are only building the software which can use the eye tracking data. So in this short video, I show you how the QtPy sees the world. So the red dot represents where is the driver looking at. And you can see when it detects the vehicles and also detects a stop sign. And we can see that this person has looked at the stop sign. And now we can see that the driver noticed the bicycle and the pedestrians. And using this information, we can really dig deep into this data to see at what point did this driver notice the stop sign and what was the driver's action right after that. And it can also give suggestions on what better could the driver have done. So this is just a pictorial representation of what you just saw. And this is how the software would look like. This is something that is still in progress. This is what we would ideally like to give to the healthcare professionals so that they can quickly review the information from their patients. So if the patient drives for an hour, we of course don't want the doctor to spend another hour looking at this whole video. So what we would like to do is to shorten this review time. So we will automatically detect what are the critical errors that this patient has done. And if there is a particular health condition affecting particular types of traffic situations, we build a custom filter for that. So basically, the idea is to be able to review a whole patient's data in just a few seconds or in a few minutes. So this is how the use case would look like. So the doctor meets the patient and the doctor is unsure whether this patient is fit to drive or not. Then they give the QtPy to them. And the patient takes the QtPy into their car and drives. And we get the data. We analyze the data and gives inputs to the healthcare professional who would make the decision about the fitness to drive of the patient. And this, by doing this, we save a lot of time for the healthcare professionals. And we provide a better method with a higher accuracy and real-world assessments. So the doctor can understand how exactly does a patient drive on the real world without leaving a hospital. That, I think, is the biggest value that we provide to the healthcare professionals. And it's also more convenient for the patients, that the patients don't need to go to the clinic multiple times. They can just order this and they do the test at home. And it's also a fair evaluation system that addresses so many biases that the existing driving assessment methods have. And in the DASH project, we had to develop a test protocol from scratch. And we luckily had so many existing protocols to build this upon. So we used VTI's experiments from a few years back, where they tested in a simulator for patients with VFL, visual field loss. And we also used the traffic worket's general evaluation protocol. And we also had the chance to speak with Veteran Affairs. It's a big department in the US that is addressing the driving assessment methods. And we also had the traffic school testing protocol that is standardized across all the traffic schools in Sweden. And in this experiment, we recruited patients from geriatric clinic with the help of Mikhail and Adrian. And the inclusion criteria for this experiment is that the patients need to pass this MMSE test with a minimum score of 24, and they should be diagnosed with early stage dementia, and they are in the process of reevaluation of driving skills. So they still have the driving license, but they're in the process of reevaluation. And how it worked in practice is that they were asked, so you have an option to either drive in a simulator or participate in the DASH. So the patients volunteered to do the DASH experiment. And also something very important to note here is that, so we have these participants doing this test with us in the car that we gave with the help of a traffic school. And irrespective of the experiment results, the patients got their results of their test. Again, we have the video. Now I just show you a short video of how it worked out in the experiments. I think in the future, this can be very useful for healthcare in this way that, for example, when the doctor is not sure if the patient's health condition is affecting or not, when there is this sort of a fuzziness, what the doctor can possibly do is that they can refer the patient the QT-PI system that we are developing, and the patient can just do what they did today in their regular environment without the traffic school teacher. So the patients are just basically doing a test on themselves. And when they drive around and then they come back to the hospital, give the box, and then we conduct the analysis, and we give this report to the doctor, who will then make the decision. Yeah. So in total, we had experiments conducted with 6 participants. And the car is retrofitted with multiple sensors from the VTI to collect the data that we need from the vehicle and also the GPS data. And the traffic school instructor sat in the car next to the patient, and the instructor gave instructions similar to how a driving license test would look like. And the patient was supposed to follow his instructions on where they should go next. And every participant wore the eye tracking glasses, which is connected to a phone, which helped us to collect the data. And I sat in the rear seat to get the data recording. And one of the inputs that we have is also that the traffic school instructor did their own assessment of the driver. So we have that point of data, which would be there anyway, and which would be used in the actual assessment of the patient's driving skills. And on top of that, we have our own data, which we compared and which we will soon see. And given the length of this project, this is supposed to be a pilot project to test the feasibility of using QT-PI as a method for driving assessments in real life. So we had to pick 5 rules that we could do well and test it. So just to get the understanding of how it would work in the reality. And these are the rules that we used in the DASH project. So we developed these protocols, and we developed the algorithms to test for these conditions. And we will go through each one of these conditions soon. And the criteria that we were looking for are these 3, which is the traffic rules, traffic safety and behavior, and also about attention and how is the driver scanning the environment. So this is the first rule. The first rule is to taking a right turn at the traffic light. So this was happening very close to the railway station in Örebro, where you have a lot of traffic, and you also have the situation where you get a right green light, and then you also have to adjust to the oncoming traffic with the bikes and the pedestrians. So we chose particularly the situations which are quite hard to do it anyway, and we took it as a challenge to do it in the DASH project. And in this, within the traffic rules, we were checking for the speed limits and also about obeying the traffic lights. And then in the second category, with the traffic safety and behavior, we were looking for how is the driver adapting to pedestrians and cyclists, and also adjusting to other vehicles, and also speed adaptation. And then in addition to that, we were also looking for how is the driver scanning the traffic light and how is the driver scanning the pedestrians and cyclists, because there is so much things happening in a very short time. I can show you a video of how it would look like from the QtPy's perspective. The green dot with the plus red indicates where the driver is looking at. And you can see the objects being recognized, and you see the pedestrians, the cyclists. Yeah, so that is how we were scanning through this environment. And then the next rule was about residential roads. In a very regular road, about where the speed limit is between about 30 or sometimes 50. And in that, we were looking for the traffic rules, which is basically speed limit checking, zebra crossings if the driver is looking for the patients and pedestrians and waiting for them, and also how is the behavior at the T junctions, and the traffic checks and adjusting accordingly, and also adapting to the construction sites, which we fortunately had during this test run. And in addition to that, with respect to the scanning and attention, which is kind of like QtPy superpower, because we could see where the driver was looking very objectively, we could do the mirror checks and the traffic sign checks, and in what distance were they looking for the oncoming traffic, and also how are they behaving at the junctions without traffic light. Maybe when you were taking your driving license exam, the driving school instructor might have told that when there is no traffic light, you're supposed to be always scanning on both the sides of the road when you're approaching a junction to make sure that there is nobody coming. So that is something that we could manage to do. And this is another tricky situation where you have to yield. So the rules in this kind of situations are not just purely white and black, but rather in a bit gray zone where you have to be aware of this oncoming traffic and adapt according to that. Yeah, so here. So this is a bit tricky situation where the driver needs to really plan in advance. And this is the fourth rule, which is the lane yielding. So you're on a road, on a 2-lane road, and suddenly it becomes 1 lane. And you have to, depending on where your position is, you have to determine whether you should go or should you let the other person go. So this is one such instances that we had. So in this case, the driver decided to wait to let the traffic pass and then go. And this is the list of the things that we were checking for each rule. We can, if you have more questions, we can discuss more after the presentation. And this is this is actually my favorite rule of all. So this is the situation about the highway driving. I know a lot of friends who had lost their driving license because they didn't do this correctly. So this is a very important rule that when you are merging via a ramp into the highway, at what point do the scan? So in this situation, we can see that, oh, sorry. Yeah, so if you see here, so the driver was going into the highway even before merging, even before he even saw where he was going to merge into the highway, he had the opportunity to check it, to do a sort of like a pre-check. Oh no, sorry, my mistake. And here you can see. So that was something that is a sign of a very experienced driver that they were planning a lot in advance when compared to a novice driver. So now what we did was, with all the rules that I listed earlier, within these 3 categories of traffic rules, traffic safety and behavior, and scanning and attention, we started to give a points scheme. If the driver has done this correctly, he gets 1 point. And if the driver didn't do it, then they get 0 points. So this is how we started to do it. And this was also rather tricky because we are doing the tests in a real environment. So the environment is never the same. So sometimes we had this challenge of there was nothing in the environment. There was absolutely no traffic. So there was nothing to check for. So things started to get more tricky. And that is where, for example, the simulator-based tests would be perfect. That because you can control the environment. But this is a trade-off between these two methods. But we managed to get a pointing-based system adapted to that. And that is what you see now. So we see here that the QT has a total score there in the first yellow line. And in the second yellow line, you see the score that the traffic school instructor gave to these same patients. So in our test, we had, out of the 6 participants, we had to not use one of the participants' data, but we have successfully got 5 patients' data. And fortunately, all the patients that we had passed the exam that the traffic school instructor has done on the patients. And these are the scores that we have for the QT. And you can observe that the scores of the QT are, in terms of percentage, are higher than that of the traffic school scores. And that is because the traffic school starts to do the assessment over the whole driving. So they look at the driving in a very holistic manner, that they take into account all the driving situations. But we only took into account 5 traffic situations. And since this is a pilot project, we could only do that much. But in the future work, the idea is to increase this number of traffic situations that we will handle. And then we believe that we're going to merge it. And we believe that in the future, when we have more and more situations implemented into the QT system, then we will have scores changing. And we believe that with the results that we have so far, that it is indeed feasible to use QT as a driving assessment tool. And apart from the scores that we got from the traffic school instructor, this instructor also gave some inputs about what they noticed in the drivers. So one of the very common mistakes that the drivers did, it's not considered as a major mistake that would take away the driving license, but something that is still important, but rather not done, is the behavior at the railway crossings. So you have this X sign when you're approaching a railroad, and it's often missed. So out of the 6 participants that we had, only 1 participant actually noticed the railway crossing, and everybody else just went. And it's something that highlights how useful the QT can be in assessing such kind of situations. And this is another situation that it's a very common thing. You always have to actively do this blind spot check and the mirror checks, but it is very often that the more experienced driver just skip it, or they do it very fast. We don't know, we never know. And in our case, we were doing this test on experienced drivers. So it was tricky to understand whether they looked at it or not. But from the perspective of QT, when we looked at the data, we saw that some of the drivers did, but some didn't. And that we could say very objectively. And this is a video of the actual traffic school teacher driving the car, demonstrating how you have to check for the blind spots and the mirror checks when you are merging onto the highway. Just an additional point of data that I wanted to show to showcase the highlights of our system. So, so that is the data side of things. And we are very happy that we had initial meetings with all the partners, and we were already happy with the progress that we had, and they are willing to continue to work with us and go for a next funding proposal, or also to look into the market side of things, like how can we launch it into the market. So we are having these discussions with our potential customers. And when we had this news viral, it went when Jesper has launched it on Örebro website. It was picked out by so many websites in Sweden, and it even reached the SVT report, and that helped us with the reach to reaching so many potential users for this system. So we had interest from many patients who some of them actually wrote handwritten letters. It was really touching to see it. And also hospitals have approached us to asking if they can put their patients into our pilot projects. But given the time constraints, we couldn't do that. But we have a list of hospitals and a list of patients who are willing to do it. So when we continue this project into the next phase, we will definitely consider that. And we also have written a Vinova funding proposal in 2021, which was unfortunately rejected due to a small technicality with one of our partners. But Vinova has invited us to come back in 2022 with another proposal, which we are currently in preparation with. And going out of Sweden, we also, during the time of the DASH project, we had some international activity. So we validated the application of QtPi in healthcare with Stanford University and Stanford Hospital, and also with the Veteran Affairs, who also deals with the medical driving evaluations in the US. So we are currently in discussions to start a new pilot project, potentially a new project, or potentially as a continuation to what we have done in the DASH. And actually also, when I had the meeting with the Veteran Affairs, so they were kind enough to share their protocol with me, what they do when they meet their patients. So we already started to implement that into the DASH project. And so this the driving assessment that QtPi can give is not just limited to healthcare. So that is the DASH side of things, but we also look beyond that into the traffic authorities, the Trafikverket in Sweden. So we recently got a new funding from Trafikverket to develop a tool that they can use as a prerequisite tool before people can go for a practical exam. In Sweden, there is a big problem with Trafikverket that about 60% of all the driving exams result in a failure. And this is a very big problem for them, and there is no way for Trafikverket to stop them from coming. So they were looking at QtPi as a tool where they can use it as a prerequisite. So we are currently in that project. And also in the USA, we spoke with the equivalent to Trafikverket there. It's called the DMV. And they have expressed an interest also to start a pilot with us. In addition, we also had 2 medical students from Örebro University who have done their bachelor thesis in topics which are connected to the DASH project. So that was really nice to have. And I think all these activities that I have presented so far, I think it's the key aspect of all of this is that the AI.ALL funding that we had received in September 2021 has been a crucial part. So this funding, for example, it helped me to fund my salary. So I don't have to think about this kind of thing. So I am in a dual role. So I'm a researcher and I'm also an entrepreneur. So it's a very tricky interjection that I am staying at. And having this funding from the AI.ALL had been a very important step, a very important support in the back. And I would say that without the AI.ALL funding, it would have been really, really difficult to achieve the progress that we have achieved until now. So I'm very thankful for the AI.ALL project funding. And also the progress that we have achieved in the DASH project is of a rather fundamental nature. So I'd like to think that it's a foundation of a very big project and also a business solution that will go into the market soon. And also we have managed to achieve several UN SDG goals during this project, primarily with the good health and well-being. And we also look forward to contributing to the ambitious goal of Sweden to have the 0 casualties on the road. So during this project, we had faced a lot of challenges. This was my first project, as I mentioned. So this is a completely new role for me. So there was a lot of learning for me. And one of the first challenges was to write the ethical approval, which I didn't need to do before that. Before I was only dealing with the computer, so no ethical approvals required. But now when I go into the real world, the ethical approval came, and we had no idea that when I wrote the proposal, I didn't think about it. And that there was a bit of a delay because of that. And I'm very happy that the AI.ALL funding was kind enough to extend the funding so that we could do the things the right way. And we are also very grateful for all the help that we received from all the people in the AI.ALL. And I think it's only because of all of their help that we managed to achieve the success that we did today. And these are we had a lot of media coverage. Fortunately for the projects, this is all the list of articles that Dash project and QtPy have appeared in the last few months. And we also received great testimonials from several people, and this is one of them from Stanford. So she said that this is a really useful tool for the patients. And also from the DMV in the US, they wanted to see that this data-driven approach that we developed is extremely crucial for the future. And they were also thinking about in the future, maybe 10 years down the line, 20 years down the line, maybe the driving licenses would look completely different from what it is today. Maybe it's just you just order it and you never even have to go to traffic worket to get a driving license. So we are all thinking together with them. But the most important testimonials that I have received were from the patients. When we had this media coverage, so many patients have approached us asking that if they were explaining their history of their medical condition, how their driving license was taken away. Every year in Sweden, about 10,000 people lose their driving licenses. And some people, I think it's fair, but some people feel that it is unfair. But what was missing until now is that the people who felt unfair, they didn't had anything to prove why it is unfair. But we would like to think that QtPy can give a platform for both the sides, for the health authorities and the traffic authorities, and also for the patients to prove objectively why they're right. So thank you. And I would like to invite Mikhail to give a short talk.
Yes. Yes, I work as a psychologist at the geriatrics clinic. And I just mentioned to Ravi yesterday that maybe we could use the data and the process data from the QtPy drive, the individual drives, to tailor a training program, probably a computer game type of thing, or something else, but anyway, something tailored for each patient to train and perhaps, in the best of cases, improve their driving ability, because you get very specific and clear data on what they fail at, which we don't have today when I test patients. And yeah, I think that could work. I'm sure it would work. I'm sure we could. It wouldn't be too difficult to write a program that would train people, but I'm not. Oh, yes. So that was just a short comment, but it would be very nice to, when you work in healthcare, it's nice to actually help people, just not deny them things in life, but to help them get better. Yeah, that was it. Okay.
Thank you.
Thank you. So is Adrian here? Hi, Adrian.
Hello, Ravi.
Hello.
Many thanks for a fantastic presentation. Really excellent, and I too have got lots of ideas and reflections. But I just want to confirm and to add to this. This is one of the points that you take up. This is a major medical issue. We have 1.9 million people in Sweden over the age of 65 who have a driver's license, and a high number of those individuals will be developing mild cognitive symptoms. And what you're providing is as you very cleverly said at the end, as a platform for the medical profession and to be a robust instrument for the patients, because it is clear in some studies that to be denied the right of driving, it does lead to other medical conditions, increased risk for depression, for example, in the individuals. And this is a very tricky area for doctors to assess and to in a pedagogical fashion try to deliver a message to the individual, and to keep that relationship healthy and ongoing, because this is a very charged. It's also a very charged area. To get your driving license taken away it really affects your daily life and your quality of life and your ability to function as an individual. So if we can get objective, validated instruments, is a huge help for us. And I can clearly see that it could also be used in general, but when we're specifically thinking about individuals with cognitive symptoms, that this is a great help. Thanks.
Thank you, Adrian. And Jan, are you there?
Absolutely.
Hi, Jan.
Hi, Ravi. Thank you for a nice presentation. When I do agree with Adrian that we have a huge possibility here to develop something that is really good. I'm involved in a number of projects concerning people with visual deficits, especially. And I have two frank questions, actually, Ravi. Would that fit this situation? Yeah.
Of course.
The first one, yes. One of the issues that we really bother with is that, as you mentioned, it could reduce the numbers of persons taking part in the exam. And one of the issues that we really have problems with is that we don't want to let people out in the street without their sufficient skills. So that's why we have a passenger, förarprövare, traffic inspector, to make sure that nobody is hurt during the exam, not just the person itself, the road users of it all. So how would, in that sense, from that perspective, a QTPI could be used as a tool from a pragmatic perspective? We cannot let people out that might be traffic unsafe, so to speak. So in that sense, it's we need to have a safe situation. Please, that was my first question. So let me ask the second one after your reflection on the first one.
Sure. Yes. So what I meant when I told about this automatic way of doing these assessments is this, that of course it will not completely take away the role of the examiner, but rather reduce it. So for example, today in Sweden, for people who are going for a normal driving license test, they maybe take 30-40 lessons with a driving instructor, but with using this assistive technology in their learning process, we could reduce this by a lot. So for example, maybe the first 5 lessons, the driver will go with the instructor. And if they're using, I'm imagining into the future, but then QTPI can say that, okay, now is the time that you can perhaps go by yourself. So we use a combination of these two things. I think having a human expert in the car is extremely important, But of course, it needs to be balanced with the need at that point.
Absolutely. I think we have the possibility to go around this, but this is an issue that you really didn't address really. So I just wanted to pick that up.
Thank you.
The second question that is more theoretically interesting is that you had 5 drivers that was successful in their performance. And it was a correlation between the results of the QT and the performance of the assessment by. I would say that you would need to be able to show that when the driver is unsuccessful,
Yes.
in order to say that you can discriminate between the good ones and the bad ones, because
Absolutely.
it could have been, yes. So we need to do a lot of more to see where the strengths are and when it's overlapping, when it's not overlapping. Who has the right? I mean, if the traffic inspector says no and QTPay says yes, it doesn't mean that QTPay is wrong. It just makes it only says that they don't overlap. So
Right.
so we need more data to discriminate between the good ones and the bad ones. So,
Yes,
yeah,
I cannot agree more. Yes, please. Absolutely.
Yes, it was really a clinical or practical consideration. I couldn't, I had to pick people that I thought would had a chance to pass. I couldn't send people who I thought wouldn't pass, because that would be safe and that wouldn't be ethical from my point of view, in my work. So that, but we would definitely, or you would definitely need a bigger range of test participants, even better ones that would pass without difficulty, and people who wouldn't pass. But yeah,
right.
For next part, maybe.
Yes. Thank you. And,
Is there someone else you want to talk before we go on with questions?
No, we can open for the questions now.
Okay. Do we have any questions here from the audience here live, first of all? Several.
Yeah, I got a question regarding the method. As you use cameras to basically see how they're looking, what happens if it's like bad weather, you can't see too much in the road? How will you deal with those kind of situations, since it's not always sunny?
Yes, that is a bit tricky situation. We also faced it in some situations. Even we did it in the middle of the summer, and yet we had the issue with the sun directly hitting into the camera, and then we lost the view at some times. So that is an issue that we are aware of, but we are currently focusing on other sides of the technical development. And we are thinking of solutions for this in the future, that we could have, we could augment the cameras. So currently we just use the camera that is on the eye tracker, but in the future we could actually access the camera that a car has. And that would give us a better visual data to understand. But of course, if it's an extremely bad weather, we cannot do anything.
Thank you.
Any more questions from the audience here? No. We have one question in the Q&A here, at least. Let's see here. Congrats for the great work and good results. What is the next step, and how far are you from turning this into a product that can be used in the real assessments?
We are thinking about an year. So there's a lot of things that I have to think before answering that question. But if I'm taking the optimistic route there, I would say an year.
A year for QT or for Dash as well? Do you see?
For me, they're both together.
Great, thank you. More questions? Here's one more. What was the performance of the individuals over time? An example, over the whole hour.
We didn't look at that in this analysis, but that is something that we can definitely look at. So we have a lot of data, but we only used a portion of the data in this analysis. So we have all this data and we will dig deep into it. And that would be very, very nice to have. That is what I also was mentioning about this episodic versus continuous assessment. So in an episodic, maybe you come across a situation only once. But if you put these glasses onto the patient for a longer duration of time, over a few days, then it would be very interesting to see how it changes. So we didn't do that in this experiment because we only had like a 35 minutes drive.
Thank you. We also have Jan raising his hand. You can go ahead with your question yourself.
Absolutely. If we have time, I have two questions again. We from BTI we do a number of studies, and we also do a number of eye tracking studies. Would it be possible to send you the eye tracking information, compare and the data from the vehicle, and to get you get a great big numbers of data points, and then you should by QtPy predict if this was a good drive or not. Would that be an interesting aspect for you? Because we have tons of data. We have big data on eye tracking and performances and so forth, but not especially on the visual deficit. But would that be an interest for you to really have big data to work with in order to increase the specificity of QtPy?
Yes, absolutely. That is the need of the hour for us.
Yes. So even if it's not the Pupil Labs eye tracking system, it's a smart eye system, Tubi systems. We could use a lot of. We even use Pupil Labs as well. So it doesn't matter if it is perfect. Then we will discuss this later.
Yes.
Thank
you, Jan.
Yeah. And my second question was, I don't know. I'll get back to you if I remember my second question.
Sure.
Sorry.
No problem.
Perfect. Thank you, Jan. Any more questions from the audience? We have about 2 more minutes here. Let me see. There's one more here, I think. One more in the chat. Hi, Ravi. Thanks for a good presentation. Can you say something about how it has been to collaborate with other areas of expertise besides the technical?
Yeah, that is a very new area for me to do that kind of things. But during this journey, I understood that that is something that I like to do. I didn't know that I had that skill in me, but it was a good discovery for me that going out, speaking with the people, that is something that I really enjoyed. It was, of course, it comes with its own challenges that when you are going out of your comfort zone into a new area and trying to learn new things, it can be hard, and it was hard sometimes, but I'm happy that we have gone through this journey together and came out successfully.
Thank you. Let me check and see if there are any more there. Well, perfect timing there, 13:59. And I am very happy that you have done this project with us too. It's been great to follow, and I'm looking forward to the future here as well to see. I'm sure it will go great. It's a good start, at least here. Thank you for today's presentation. We have recorded it and can send it out as well afterwards here to you as well, perhaps the presentation if needed as well, and with the contacts, and please get in touch as well.
Absolutely. Very welcome. Thank you so much.
Great. Thank you all for today. Have a great weekend.